So hi, good evening. Slides are not up yet.
Oops.
Okay. So my talk basically is about building scalable web apps. It's not super technical. It's kind of like high level. As you can see by the cover image, that is an example of a non-scalable solution. So it's not a web app, but I thought it was funny. Who am I? I recently became Mindvalley CTO. If you don't know who Mindvalley is, it's kind of strange because you're sitting in the office. I'm also still a sysadmin. I've been running the systems for Mindvalley for about 2 years, introducing some DevOps stuff. Most of my day is spent staring at terminals. I'm also a technical architect. I work with the developers to figure out what kind of stack they're going to use, what the app's going to be doing, that kind of stuff. So just to get a pulse check tech-wise, can I see a show of hands who's familiar with at least one of these technologies? That means you've heard of it, you kind of know what it is. All right, so say about 30%. Who's actually used one, like installed it, set it up, configured it? Yeah, about the same. Who could debate the finer points of Nginx versus Apache? Yeah, another speaker. Yeah, all the speakers. Okay, so not many. In this talk, I'm going to cover a basic introduction to scaling, scalability. What is it? 5 points to think about when you're building a web app, and 5 things you can do to make your web app scalable. So just to get a definition out of the way, first, scalability versus performance. Performance measures the speed with which a single request can be executed. So how fast one request can be executed. Scalability is the ability of a request to maintain its performance under increasing load. So that means however many concurrent users you have, the performance stays the same if your app is scalable. So scalability can give you performance, but performance can't guarantee you scalability because it's only about serving one request at a time. There's basically 2 types of scaling. Like 10 years ago, what we virtually always had to do is called vertical scaling, which is known as scaling up, which is just adding more hardware. You add more CPUs, more RAM. If you can't add any more CPUs and any more RAM, and you're still running out of resources, you're kind of screwed because there wasn't much else you could do. What we've moved to now is more what we call scaling out, or horizontal scaling. The picture is actually Google's data center. So they were one of the pioneers for this. They used commodity low-end hardware, and a lot of it. And then they spread all their applications across multiple physical hosts. So this is how the whole cloud was kind of built on the scaling out model. Lagging.
It's not scalable.
Yeah, sorry, the projector's not scalable. So, just some quick pros and cons, scaling up versus scaling out. Obviously, scaling up, it can become very, very expensive because you have your baseline hardware. To buy the kind of hardware that can support, say, 512 gig of RAM, the motherboard alone is very costly. And then you need 8 processors. The cost gets exponentially higher when you scale up. Obviously, it's a single point of failure, which if you're scaling stuff, you do not want that. Its only real advantage is it's less complex to manage because you only have one server. Another downside is it has a finite limit. There's only so many processors and so much RAM you can put in one chassis. And when you reach that, you have to start scaling out. So scaling out, especially in the past 3 years, it's quite cheap now. You've got cloud, you've got VMs, VPS, commodity hardware, you've got Amazon AWS, Rackspace, Linode. You have a lot more options for building a scaled out architecture. Obviously the pros are it increases availability. The cons would be the management can become very complex when you're dealing with a lot of servers. Like in Mindvalley, I think we have about close to 300 nodes across Linode, Rackspace, and Amazon. So just dealing with the management of that many servers can become difficult. Deployment, obviously deploying a new code can become very slow. We have one cluster that has about 60 servers serving the same bunch of websites. So deploying a large site on that cluster can take an hour. So those are basically the only downsides, which I find are quite minor downsides compared to the upsides. So we'll move on to the points to consider. One is that logging is supposed to be a gift, but it's not playing. Logging can get out of control really fast. Like if you have 100 servers, your web server's logging, your application's logging, usually the application handler like PHP or Unicorn is also logging. So if you have 100 servers with 4 sets of logs for every website, it can get really crazy. It's one thing you have to think about quite early on. It's fairly easy to get around it now. You can use a centralized log management system. We're using Papertrail in Mindvalley, but locally is pretty good as well. So basically, you send all your syslogs into the cloud. It's searchable, it's archived, you can put it onto S3 if you want. User sessions are something else you have to think about when you're spreading across multiple machines. So I really love Redis. I like to use it for multiple things, but it's really, really good for user sessions. But you could use any fast in-memory store. Memcache is fine. If you're already using it, you can use that. Remember to invalidate your sessions. We had one application which just generated so many sessions it kept crashing because it was filling up all the memory. Third one is just monitor everything all the time. Like you can't. There's nothing really more important than this. Because if something goes wrong or the performance starts going down, you need to know why. So you need data. You need to make data-driven decisions. We use Moonin. It's free. It's open source. It's really easy to set up. It has plugins for pretty much everything. MySQL, Apache, NX, Postgres, Redis. You just put the plugins in and you get a nice graph. There's a Moonin graph later, so I'll point it out. Fourth point is you have to think about where your bottlenecks are. 90% of the time it's usually the database. So the worst culprit is usually MySQL. Sometimes it can be the file system. That's not so common now when most of the hosts are actually offering SSD hosting. So Linode recently, which is what we use predominantly, Linode recently completely switched to SSD, which makes a lot of difference when it comes to the file system I/O speed. We have had a few cases where we've actually saturated the network bandwidth. This happens on Amazon as well. It's not that they don't have the bandwidth, but when you open your account, it has a cap. So if you start getting close to that, you need to raise the ticket and ask them to raise the cap. There are times, especially if you have a spiky traffic profile, it's possible to saturate the network bandwidth. Obviously, if you have monitoring in place, you will figure out what happened. The fifth would be, like I mentioned, the traffic profile. These are real pictures from Mindvalley websites. So this was one webinar we did. We had 22,000 concurrent users. Now you can see the top is connections and the bottom is bandwidth. And this is DNS round robin across 4 load balancers. So it's probably about 4,000 connections per second and about 200 meg. So if you have this kind of traffic profile, you have to build things differently. Because the easier way to build things is when you have a linear growth. So say if you have a mobile app or a web app and you're slowly gaining users, you can kind of see how your bandwidth and your usage is going up and you can add more servers. Whereas for us, you can see the baseline is quite constant, but then we have these huge, like 40,000% spikes every few weeks. So architecture-wise, again, this is actually a Moonin-like graph. So if you have monitoring and you have these kind of spikes, you can build your architecture to deal with it. Some of the things you can consider. The most important one is caching. So there we go. Okay. So this is actually a real graph from one of our apps from Moonin. The two people that did this are here. This was built by Sehoy in Python. So you can see the blue part is the CPU usage. When the blue part stops being spiky is when the caching by Callum was implemented. So you can see how much, this is an API for a mobile backend. So you can just see how much difference caching makes. This is just, you can ask Callum if you want to know more. Okay, so you can try and cache everything you can. Cache objects, cache sections, cache API requests. Especially if you do something read heavy, just cache the whole page if you can. You can have a page cache. Rails has something called partials caching, which you can look into as well. But this graph, actually sometimes the CPU, the graph's normalized, so you can't see it, but the CPU was hitting 800% whenever they did a push notification, because it's a mobile app API for the backend. So just by implementing caching, and the graph was the same, this was for the web server, the graph was the same for Postgres, for the data store. So caching is super awesome. Obviously, what else you need to do is understand the tools you're using, the stack you're using. This was a client I had a couple of years ago who was having a real problem with the MySQL backend. You can see this is a graph of load average. So the general rule is you can have one load per CPU core. So this is a 4-core machine. So the maximum load you should see on this is 4, but you can see it spiking all the way up to 10. And this was something really simple. So best thing you can do is know your tools or your stack, or hire someone that does. Because all I did here was turn on the query cache. For some reason, if anyone's familiar with MySQL, this guy was running MySQL without a query cache, which is just kind of nuts. You want to optimize, but you don't want to overdo it. So what we usually say is don't prematurely optimize. If you don't have the traffic, don't worry about it too much. And build for scale if you can, but don't get complex, obviously without a good reason. But you know, if you think you always hope your application is going to have a lot of traffic. So just bear in mind when you're thinking of the architecture, how you're going to build that to be scalable in the future. Another thing which we found building web apps is probably the second most important after caching is use queuing. Queues are amazing and they take the load off the data store. So we're using Ruby for most of our stuff, but the system I showed just now is using RabbitMQ. But we use Kafka as well for the Ruby apps with Redis as the queue store. This, especially if you have a spiky kind of traffic profile, this really takes the load off the database. So if you're struggling with MySQL or PostgreSQL and it can't write fast enough, just put a queue in the middle. Like the queue will take all the requests, put them into Redis, and then it will feed them into the database as fast as it can handle it. So if you're having issues with your database load spiking, or you can't get the data into it fast enough, just look at putting a queue in the middle. You can put something like RabbitMQ is language agnostic, so you can just have a RabbitMQ server. It can use multiple kinds of storage engines. It makes it much less necessary to scale the database, because obviously the queue is taking the brunt of the load, and it handles the burden of spiky loads. Because a lot of times if you have a really big spike on a traditional relational database, it will go down, because it has a finite limit of connections it can handle at the same time. So we have one tool which processes email signups, and it was constantly going down. Whenever it had a bit of a spike, it would go down, because originally it was built on MongoDB, which was a mistake. So now it's on Redis for the queue and Postgres for the backend, and it has no issues. Even if we have huge spikes, we've had 20,000 items in the queue at the same time, and it will just keep going. Eventually it will process all of them. One more thing you can do is ditch search. By ditch search, I don't mean get rid of it completely, because obviously a lot of things do need search. This is an atomic bomb explosion, and it's what happens when you do a full text search on MySQL. Yeah, don't do it, it's not designed for it. Get whatever data you need to search and put it in a storage engine designed for search. So Solr, Lucene, Amazon Elasticsearch, these are designed for searching. So if your application or your site has a search functionality, I don't know if Yushu is going to talk about it, but one of the issues with Relation Insider was the search as well, and how to scale it. Because it is very database intensive. Obviously, in a relational database, you have to join multiple tables to do searches, which is always bad. What else you can do is leverage, there's a lot of services out there, especially in the last 5 years, things have changed a lot. 10 years ago, we didn't have these kind of tools. We had to build big servers in Ames or Jarring data center, and we had to figure out, how big was the pipe and how many servers we needed and what we could do. But now you have all kinds of services online which can help you with the scalability of your app. We have the CTO on app who's going to be talking about their CDN. So if you have any kind of app, use the CDN. It takes so much burden off your web servers. All your static files, your images, your videos, your JavaScript, your CSS, serve them with a CDN. There's CloudFront, there's Edgecast, there's Max CDN, there's a whole bunch of them. You can find one that suits what you do. If you're using something like WordPress or another content management system, you can consider using a specialist host, something like WP Engine. Does all the scaling for you, all the optimization for you. You just put your WordPress site there, and that's it. You don't have to worry about caching or time to first byte or CDN or anything. You just put it there and it's done. So if you have something that suits a specialized host, definitely look at that because it takes the burden off you having to worry about it. Another common point of failure is DNS. So you might want to look at using a higher end DNS service. We did have an issue once where GoDaddy DNS got DDoS, and half our domains went down because GoDaddy wasn't resolving anymore. So you can look at using Amazon's Route 53, Ultra DNS, DYN. There's a whole bunch of high-end multicast, anycast DNS services which you can use. If you're using something which has New Relic support, I fully recommend get New Relic on it, profile it, see where the bottlenecks are within the app. There's usually some low-hanging fruit you can fix quite easily. And that's it, 18 seconds left. There's no questions, so yeah. If you have any, tweet me, or preferably put it in the Facebook page or event so everyone can benefit from the answers. And yeah, later let's talk about scalable architecture and do some spawning. Yeah, thanks.
Thanks, Gareth. Those guys over there, do you want to try to squeeze into the central area here, if you like? No? There's a sidebar there, you can sit as well.